Hello, this is Mr. Huber. In this lesson, we're going to learn about solving quadratic equations by graphing them. Okay? We've solved quadratic equations by factoring. So in this first example, y equals x squared plus 2x minus 3, if we recall by factoring, we would want to set this equal to 0, and then we would have x plus 3 and x minus 1 as our factors. And we could set each factor equal to 0. X plus 3 equals 0, x minus 1 equals 0. And when I add 1 to both sides on that second side, right, I'm going to get x equals 1. And in the first factor, I'm going to subtract 3 on both sides, x equals negative 3. And my solutions would be negative 3 and 1. Right, these are the x values where the y value is 0. So if I wrote that as an ordered pair, it would be like 1, comma 0, or negative 3, comma 0. Well, when I graph, I can look for those points on the graph. Those are the x-intercepts. So the places where the graph crosses the x-axis and has a y value of 0, those would be the solutions of the equation. So we can solve quadratic equations by graphing them and finding those x-intercepts. So let's solve that same equation by graphing it. So if we want to solve this by graphing, I'm going to use a table of values, and I need to start with x equals negative 2 over 2 times 1. X equals negative b over 2a. So that's going to be negative 1. So my axis of symmetry would be negative 1. And then I'm going to make a table of values. So x and y. My table of values, negative 1, negative 2, negative 3, 0, and 1. And now when I plug those values into the equation, right, I'm going to get negative 3 squared, which is 9, minus 6 is 3, minus 3 is 0. I plug negative 2 into the equation. I get negative 2 squared is 4, minus 4, right? Remember, I'm plugging those in. I'm taking the negative 2 and I'm plugging in here for x, right, to find the y value. So I have negative 2 squared is 4, minus 4 is 0, minus 3, that'd be a negative 3. And then I've got negative 1. I plug that in to both places where there's an x. I get 1 minus 2 is negative 1, minus 3 is negative 4. And I'd have the same points on this side. And we could see when we graph this, right, we could already identify here, negative 3, comma 0, 1, comma 0. These are going to be my intercepts. Those should be my solutions where it crosses the x-axis. Let's graph it all the way. So I'd have negative 3, comma 0 right there, negative 2, comma negative 3, negative 1, negative 4, 0, comma negative 3, and 1, comma 0. And when I graph my parabola, right, I can see my intercepts here and here, negative 3 and 1. So by graphing it, I would find my solutions right there and right there. My solutions would be x equals negative 3, x equals 1. The same solutions I got through factoring. So graphing, find the x-intercepts. Those would be the solutions for the equation. When you graph a quadratic equation, you could have 3 different scenarios. One like we just saw, where we have 2 solutions, right? We have a parabola either opening up or it could open down, and it goes through the x-axis 2 different times. So you'd have those 2 solutions because you have 2 x-intercepts. We could have one solution. If the vertex is right on the axis, right? There's only one point where this graph touches the x-axis. We have one solution. Okay? Or we could have no solutions, right? We could have a parabola like this that opens up and it's all above the x-axis, and there are no points where this would have a y value of 0. So there'd be no real solutions. So we want to look for all 3 of those possible cases. And let's graph some and see what happens. So in this first example here, number 1, we're going to solve this by graphing. So in order to solve this by graphing, we're going to make a table of values. So we find the axis of symmetry. If I do the axis of symmetry, x equals negative b, so that'd be a positive 6, it could be negative negative 6, over 2 times 1 is 2, I get 3. When I make my table of values, okay, I'm going to put a 3, then I'd have 2 and 1, 4 and 5, and when I plug those values in, I plug in a 1, I'll get 0, 2, I'll get negative 3, 3, I'll get negative 4, also negative 3, and 0. So you should be able to find those. If you're not getting those values, let's work on how we're plugging numbers into the equation to get those. And if I graph this, I'd have 1, comma 0, 2, comma negative 3, 3, comma negative 4, 4, negative 4, and 5, comma 0. And again, even from the table of values, I should be able to see it looks like these are going to be my intercepts because those are where my y value is 0. So I'm going to draw my parabola through those points, Yep, I can see right there my solutions. My solutions are going to be x equals 1 and 5. Those would be my two solutions for that quadratic equation. All right, now let's do number 2 here. We can see this isn't set equal to 0. So just like solving by factoring or anything else, we want to have it set equal to 0. So I'm going to need to subtract 1 on both sides here. So I subtract 1, and I'm going to get the equation negative x squared plus 2x minus 1 equals 0. Okay? And now I'm going to make my table of values and start with my axis of symmetry. So for my axis of symmetry, I'm going to x equals 1. And now I'm going to plug those values in. Right? So I'm going to get 1 as my middle number in my table of values. And then I'm going to have 0 and negative 1 and 2 and 3. When I plug those in, negative 1 is going to give me a negative 4, then negative 1, then 0, then negative 1, and negative 4. All right, so when I plot these points, negative 1, negative 4, 0, negative 1, 1 comma 0, 2, negative 1, and 3, negative 4. And when I graph this, right, we can see that we have the one point right there where it crosses the x-axis, where it touches it. The vertex is our only solution, right? When we plugged in an x value of 1, we got a y value of 0, so our solution is x equals 1. Right? And you could check this, right? Take 1 and plug it in and see if it makes this true. It'll be the only number that you could plug in there and make that true. So it has one solution for this particular quadratic equation. All right, now let's graph number 3. Again, we need to get it set equal to 0, so we're going to subtract 4x on both sides. So that's going to give us x squared minus 4x plus 7 equals 0. So we're going to start with our axis of symmetry, negative b over 2a. So it's a negative negative 4, which is 4 over 2. So x equals 2. And I can make a table of values here. And I graph this. So I'm going to have 2 as my middle of my table, then 1 and 0, 3 and 4. All right, when I plug those in, when I plug in a 0 to my equation, I'm going to get 7. Plug in a 1, I'll get 4, 3, a 4, and also a 7. So I graph this 2 comma 3 as my vertex, and I can just think about what happens when I graph something with a positive a value. It's going to open up. So if this is my vertex, it's going to open up. It doesn't look like this is probably going to cross the x-axis anywhere. All right, let's graph the rest of the points. We can just see the whole graph to make sure. All right, so we can graph all 5 of those points, and yes, indeed, we're going to have a parabola that opens up that has no solution. Okay, there's no point where this crosses the x-axis, no x value with a y value of 0 for that particular equation. All right, so keep in mind when you're graphing, no different than graphing before, find the middle x-axis of symmetry, the x value, that then you can build your table from, graph those points, and we're looking for the intercepts. Those x-intercepts where the whole equation has a value of 0 are the solutions. All right, we're going to see something about a function here next. Before we do, though, we'll break for the first host of the long-running show Saturday Night Live. Who is the first ever host? I'll give you a couple clues. It happened on October 11th, 1975. This is the particular person. You may or may not recognize a popular stand-up comedian with numerous specials and albums, an influential social critic and comedian. He covered everything from politics to English. George Carlin. George Carlin. He also hosted once again in 1984, but on October 11, 1975, was the first ever host of SNL. All right, let's find the zeros of a function. Okay, we're going to do it by graphing. So the zeros of our function are when the function would have a value of 0. Right? So we're putting a 0 in there for the f of x. So we really are finding, like we did before, when will this be equal to 0? So we want to find the intercepts. We want to graph it just like we did any of the other problems before. So my x equals negative b over 2a, so negative 4 over 2 times negative 2. It's going to be 4 over negative 4, which is 1. So I have x equals 1, and now I'm going to make a table of values. So 1, and then I'm going to plug in 0 and negative 1, and 2 and 3. When I plug those values in, when I plug in negative 1, I get 10, 16, 18, 16, and 10. Right? So now I want to graph these. Right? So I'm going to draw out a graph here that we can plot this on. So I'm going to graph this. Okay? And we're going to say negative 1, then we'll say 1, 2, 3, 4. Make sure that when you draw a graph, okay, when you do these, you are labeling a scale, so we know what you're counting by. We can see where points are located. I'm going to go by 2s on my y-axis, so I'm going to have 2, 4, 6, 8, 10, 12, 14, 16, 18. All right, that's as high as we need to go, it looks like there. My vertex is at 1, 18. So I'm going to graph these points. Right? So when I plot these points, I'm going to have negative 1, 10 right there. Right? I'm going to have 0, 16, 1, 18, 2, 16, and 3, 10. And if I drew a graph of this, right, I might go, okay, my graph goes like this, and if I'm trying to solve it, well, where exactly is that going to hit the axis? That might be difficult to tell. We need to be a little exact. We can't say, oh, I think it's somewhere around here. Oh, it looks like if I kept that going, you know, maybe something around that. Okay, so we might need to extend our table of values past those points, right, depending on what we're trying to graph. So let's go back and get some more points. So I'm going to plug in a 4, all right? When I plug a 4 into this equation, I will get 0. So I know 4, 0, and then I have to extend that on the other side, negative 2. It's going to go through at negative 2, 0, right? If I put that point on the other side, it's symmetrical. So once I know 4 is 0, the negative 2 should come out to be 0 as well, as we go the same distance on both sides of our axis of symmetry. And now if I graph this, right, I've got my parabola there, and my solutions, right, it says find the zeros. The zeros are the values of x that when we plug in give the whole function a value of 0, right, the intercepts. So remember, solutions, zeros, the x-intercepts, those all mean the same thing. So these right here are my solutions, right? So x equals negative 2, x equals 4. Those are my two solutions. Okay, those are also the zeros, the x-intercepts. So we can solve by graphing, by finding those intercepts, and remember the terminology that really means the same thing, right? So graphing, quadratic equations, you're finding where does the graph cross the x-axis. Those x values will be the solutions for the equation.